Hi, my name is John. I'll be going over parabolas with you with the directrix, the axis of symmetry, and a host of information, including what's called a p-value. This is reserved for advanced algebra 2 or pre-calculus, depending on which school you attend. Anyways, here's the basic information. Parabola, we have to understand the definition first. Parabola is defined as a locus of points, an infinite set of points actually, calling that point xy on a two-dimensional surface. We call that a plane. By the way, it's my definition, pretty close to other books' definition, where a point called a focus, the focus is h comma k, so I'm going to put h comma k right there, and a line called the directrix is such that the perpendicular distance between x and y and the directrix, so when you have a line like this, it's always perpendicular to the directrix right over here. We call that the D, not the L, is equal in distance from xy and the focal point. So this distance has to equal that distance. This distance right here has to equal that distance right here, and etc. That distance right there has to equal that distance right there. Doesn't really look like they're equal, but it should be equal, so we should make this a little bit flatter maybe. But you get the point. You can go through the equations. Most books have the derivations of how the parabola is formed, but that's the basic concept of the parabola. Note that the shortest point is called the vertex. So here it is right there. The shortest distance from the focal point to the vertex is the vertex to the directrix. So this distance, by the way, we call that P. We call this distance negative p. We'll go over the definition of p later on. Anything else? Oh, one more thing. This is called the AOS, axis of symmetry. This one book that I'm using right now, they call it just the axis, and it's really confusing because you have the x-axis, the y-axis, axis of symmetry, but they just call it the axis. So it took me a while to figure out what they meant by the axis. But most books will call this the axis symmetry because it's symmetrical, mirrored on the left and the right. Okay, so let's get started. Before we get started though, this is like y equals x squared, and this is going to be like x equals y squared. So that's when it goes left or right, it's going to be the y is going to be squared, and of course the up one, the basic one, is over here. Excuse me, let me move the sound just a little bit. The x is going to be squared. It's going up or down. Okay, so we got that down. The standard form for a parabola. There's two different forms. Y minus k quantity squared is equal to 4p times x minus h. That's going to be either left or right. We know that because the y is being squared here. On the other case, let's use another pen. Let's use blue this time. X minus h squared is equal to 4p times y minus k. If it's the x is being squared, then it's going to be up or down. Sometimes some books will have the 4p on this side of the equation. It's going to be 1 over 4p times, and they're going to get rid of this one right over here. So sometimes the 4p is 1 over 4p on the right side. It doesn't really matter. They're the same form of the equations. Okay. So we talked about the definition of p a little bit. We said it right over here a little bit earlier. It's the distance from the vertex to the focal point. So p is defined as the distance from the vertex to the focal point. And if it's positive, remember I said from, so starting from here, the vertex, if you go up, it's going to be positive, and if the focus is going to go down, it's going to be negative. So if p is greater than 0, which means it's positive, right? Then it's going to be an up parabola. If p is less than 0, then it's going to be negative. Less than 0 means negative. It's going to be a down parabola. So you can kind of tell if it's an up or down parabola by this positive or negative. So that's our definition of P. It's the distance from the vertex to the focal point. If it's going left or right, it's going to be, again, here's the equation. Y minus k quantity squared is equal to 4p times x minus h. There it is right there. And we said it earlier, since the y is being squared, it's going to be going to the right, or if a is greater than 0, I'm sorry, it's not a, the p-value is greater than 0, it's going to be going to the right. If p is less than 0 or negative, it's going to go to the left. Okay, so that's how you can tell if it's going left, down, up, or right. What is the axis of symmetry equation-wise? Well, it depends on which way it's moving, going up, down, left, or right. We know that the p-value is going to be added to the focal point somewhere, so it's the focal point plus p, whatever that point p is. It's going to be in the x or the y. So we'll actually do some problems with something like this. The directrix, what is it? It's going to be y equals the focal point minus the p-value, or it's going to be x equals the focal point minus the p-value. Okay, whatever that p-value is. And we're going to figure out what that p-value is a little bit later on. So let's get started. Do some examples. Let's do example number 1. Find the standard form of the equation of the parabola with vertex at the origin and focus as at 0, 4. So we're going to draw it out first a little bit, see what it looks like. And here's 0, 0, that's your vertex, is at the origin, right there. And the focal point is at 0, 4. So, I forgot to mention one little thing here. The equation of the parabola is going to be always wrapped around the focal point. No matter if it's a hyperbola, a parabola, an ellipse, or a circle. A circle has only one focal point, but it's going to be wrapped around it. So it's going to go in the up direction. This way, something like that. Okay. So what is the equation of that? Since it's y equals x squared in that form, you can go x minus h quantity squared is equal to 4p times y minus k. We know that the vertex is at the origin, which is 0, 0. That's your h, that's your k. So this time this is the vertex right over here. So we plug it in here, and so it's going to be x squared is equal to 4p times y. We have to figure out what the p-value is. By the definition earlier, I said it, it's the distance from the vertex to the focal point. So the distance from the vertex to the focal point is plus 4 units. So my p-value is going to be 4. Plug it into the equation. Y is equal to, and I divide it by, that's going to be 16 right over here. Divided by 16, 1 over 16, x squared. There's my equation of the parabola. And if you want to work it out, let's see what it looks like. Y equals, I use my calculator here, it's not coming out very well, but gotta shine somewhere. But it's not working out that well because of the angle involved. So we're not going to use the calculator right now. Okay. Example number 2. Find the focus of the parabola given by the equation. This one's a little bit more tricky. Takes a little bit more space. So I'm going to rewrite this as move this on the left hand side of the equation. Negative 1/2 x squared minus x plus 1/2 is equal to y. And since x is being squared right here, it's going to be in the form x minus h squared. H is go with the x is equal to 4p times y minus k. So I have to multiply everything by negative. I'm going to multiply by negative 2 to the left side, 2 to the right side. When I multiply that, I want to get rid of this negative right here. So it becomes x squared plus 2x minus 1 is equal to negative 2y. We're almost finished. I like to move the constant over and complete the square. So x squared plus 2x plus something equals negative 2y. I'm moving the 1 to the right side, so I added 1, and I have to add something to the left side and to the right side. Completing a square, I take this number, divided by 2. You learned about completing a square in the previous video set. So take that number, 2, always divide it by 2 and square it. You're going to add 1 to the left side and add 1 to the right side. Let's factor this out. It becomes x, drop the x, drop the plus, and half of 2 is 1 squared equals negative 2y plus 2. We're almost done. We got it almost in this form, the standard form. Okay, so it's going to be x plus 1 quantity squared is equal to, I'm going to factor out the negative 2 here. It's going to be y plus 2 plus 1. Right? Not quite, because if I distribute that out, it becomes negative 2y. That becomes minus 2, so I actually have to put a minus there. Sorry guys, did that on purpose, just so that you don't see that. This is a common error that you'll make. So, find the standard form of the equation of parabola. We got into the standard form with vertex at the origin. No, I'm sorry. Find the focus of the parabola given by the equation. That's part 1, example 2 now. So we have to find the vertex first. The vertex is h comma k, which is h goes with the x and the k goes with the y. It's the opposite of that. The vertex is equal to negative 1 and then plus 1. So there we have the vertex. Find the focus. Now, since we know that it's going to be x squared, it's going to go up or down. It's going to go, it's negative on this leading coefficient right here. So it's going to be minus, which is going to make it go down. So that's what the parabola looks like. Sorry, can't quite see that. It's going to go down because of this negative right here. In fact, let me highlight it with, here it is, negative right there, and then negative right there. Okay. So there we have certain parts of the equation. Okay. We got, this is our p-value. So 4p has to equal this portion right here. So I'm going to highlight this. This is pretty important stuff. So I know that this part has to equal that part, or 4p has to equal negative 2. Solving for p is equal to divided by 4 to both sides, negative 1/2. We know that p is negative. It's the distance from the vertex to the focal point. So since it's negative, we know it's going to go down. We start at the vertex. We're going to drop it to the y direction because it's going down in the y direction, minus 1/2. So your focal point is going to be negative 1, and then minus 1/2 is going to